Now it exited. Now this has another monitor now. So I can only use 2 to 3. When I connected to that, I can only use that, I think. You cannot do. You can only, you have to use this. See? So I can draw things, it will appear there. That's what I was planning. But the problem is now this become another monitor. This is one monitor, this is another monitor now. Mirroring my this screen. This is now this is extended. So you clicked on extended, right?
Correct.
So now this become another screen. So now 3 screens are there. See, iPad is one screen, that is one screen, and laptop is one screen. I can only mirror this laptop screen for some reason.
Yeah, right now you can only mirror the laptop screen. You need 2 screens, is it?
No, I thought I'll, instead of writing there, because camera cannot.
No, that you can always pan the camera.
Okay.
Yeah, it's much simpler to do that than to have one more.
Okay. I thought I'll write it here and. No, it's gone, bro. It's the mirroring is gone.
We can move the board here, but we can also.
Now it is mirrored. But the problem is now, I don't have.
Yeah. I think there we can put on.
Instead of notepad, go to notepad.
See, now it came here, right?
Correct.
I can do all these things, but the problem is now this is not in YouTube. This is what in YouTube.
That's fine.
So
We'll pan the camera, so the camera will then capture it from here.
okay.
Yeah, don't worry.
Cool.
So
You remove this mirroring, I will tell you. Or you can bring a notepad here. Bro, you bring a notepad here.
And then share the join the screen over there.
You just simply move
This is YouTube, right? I don't know how this thing works. Anyway, leave it. This has a lot of personal things. That's why I didn't.
yeah, you can avoid it. We had a situation yesterday.
Because it is streaming, right?
Yeah, you please avoid.
I have a lot of these photos. Mirroring is fine because that's become a different monitor altogether.
It's fine, probably this is not a problem.
Yeah, I think
and
this
we'll
will
pan
be
the camera.
Yeah, this will be good. No,
Okay, so now we've got to capture Gowtham. Gowtham, is it?
Yeah, it is there. No, one, you just click on human button.
Okay.
It's already tracked. Gowtham, you just move here.
Yeah, I think it should be.
No, it is not.
It's not moving.
Can you just
Yeah, okay.
Now is it moving?
One second. Now you.
No. You have to manually do it, I think.
No, one second. Focus. Little come front. Oh, sorry, I'm pressing the wrong button.
Gowtham, can you say something?
Now?
Hello? Hello?
Yeah, you can.
Okay, yeah.
Able to hear? Okay.
Now it's tracking.
Okay.
You can move.
It's moving, I think, right? It's moving. Okay. I'll just set up this repo. I haven't set up the repo yet. Let me do that.
No, this laptop.
This is mine.
Okay. You can come in the front. Yeah, you can take the keys also. Thank you.
So you don't want this one, right?
We don't need this. Come, Rajesh, you can come in the front and write your name. Probably before we leave for breakfast, I think one quick thing is if people can know where the washrooms are. And
Washrooms are just behind this.
See, I can, there is a,
okay, folks, can you please pay attention to this?
you can connect to the secondary case. It's a Pluto, P capital, LU, it's a 0 at the rate 25. Accelerator guest. Secondary case. Connected, right? Password P capital, LU, O, it's a 0. 0 at 25. Connected, right?
And if people want the references to
Yeah, built in.
It's, yeah,
Yeah, it's here only. You can,
the pantry.
yes, thank you.
Okay, great, all right, I think we are
Everything
already
is
over
all,
an
no,
hour.
here, everything is here.
Thank you.
I just have it on the camera, so whether it is going to write something.
Yeah.
Gautam, just want to confirm.
Hmm.
Can you just move here and is it going to focus?
Yeah, of course.
It is moving, but board, will it come? Okay, it is coming. Okay, okay, all right.
A little, you have to come till here if a board
Uh-huh.
focus.
This marker, if I can, I think write it like this, right? So it should be able to track.
Yeah, correct.
Right, it is able to track, right?
Yeah, correct.
Okay.
Little after, I need 1 minute.
Okay, what we will just speak a little loudly.
Okay, okay, got it.
This is
Okay.
good.
Just 2 minutes. Let me set this. Yeah, I just.
Okay, until then maybe people can introduce themselves while Gautam is setting up. Let's start with you, Kannan.
Yeah, my name is Kanan. I work as a SRE at Glean. I have more than 12 years of experience in application support, IT support, sysadmin, DevOps SRE. That's how I transition where I am right now today. Yeah, I recently joined Hasgeek, sorry, the Rootconf actually took a membership. I know about it for quite some time, but I was always,
Okay.
to go for it. But yeah, I just enrolled it, and yeah, in this workshop it was really quite detailed, and it's a mix of Go plus networking plus and everything.
Right.
It's for all generally stuff. So that's why I just joined and looking for further interesting sessions.
Okay, great.
Okay, great. Let's go from, okay, Agastya and then you in the middle and then Rajesh. Sorry, I don't remember all the names.
Yeah, so I'm Agastya and I work as an infrastructure engineer at ThoughtWorks.
Okay.
I have been working in infra for about 3.5 years now.
Okay.
And yeah, I know Rootconf because I volunteered last year at the conference as well. Yeah.
Great. Okay, thank you.
Yeah, I'm Manav. I'm working as a SRE in Blinkit.
Okay.
The topic of the conference was interesting, so I took a membership last year and
Okay.
just started attending sessions.
Okay. Okay. Great. Thank you.
Hey, hi, this is Rajesh. I work for Toast as an ML platform engineer.
Right.
So currently exploring like a lot of other tech stacks and just find it, I find it like really interesting topic
Okay.
as well. So yeah, like looking forward for the session.
Great. Okay. Thank you.
So Gautam, maybe you should
Yeah.
introduce yourself.
Right. First. Right. Yeah. So I'm Gautham. So I work here at Acceldata. So this is where I work, and I work as a senior staff engineer, and I've been doing Go for like around 7 years right now. So before that, I used to be a DevOps, and before that, again, I used to be a PHP developer. So long way. So 13 plus years of experience in this industry right now. So this workshop particularly, right, so about Go networking, right, so in the past couple of years, right, so when I started working here at Acceldata, I started doing a lot of these CLI based applications, basically for deployment purposes and things. So I joined here as a DevOps initial member, DevOps team initial member, and then I had to develop a lot of these CLI tools, automation, and before even I joined here, Go was already adopted and then they were using it. So when I joined here, I started learning and started doing Go related things at Acceldata. And in the last couple of years, we started developing a lot of microservices and a lot of other services other than CLI. We started developing a lot of other things also in Go. So in the last couple of years, I learned a lot about networking, especially like using microservices and things. So when I had interaction with multiple other people, even within the team, even outside, I realized that there are a lot of these basic things. We work every day in Go and this network related things like servers and clients, but we don't really get deeper into the underlying concepts, or whenever an issue comes, the navigating through multiple configurations and things. I thought we can do better than that from whatever I learned. So I thought I'll take a workshop on that, and then I actually did an internal workshop also within my team, and then they also learned good amount of things. So I thought, why not put it outside and then take this up for everyone else as well. So that's how this started, and then I'm here right now with this. So yeah, let's get started, and I can see this presentation. Let me put it into the presentation mode. Right. Yeah. So first thing I wanted to say is like we will have a boundary right now because networking is very vast. So many things that are there, and then I wanted to be very clear that what we will cover and what we are covering, and we will cover only those particular pieces, and we will see like if this thing goes better, like maybe I'll try to add up more things and then I'll come up with better advanced ones. So we will cover the TCP/IP stack, not that complete OSI model that we studied in college or whatever. So we will talk about this specific to application layer, transport layer, and a network layer. We'll just stick to that part. So because as a programmer, our just give you an example, right? So, for example, if so I have this, so this I'm just trying to ping a particular domain. So this will go through my default interface, which is EN0, which is 1500 MTU. So now I am sending a packet size of 1470. So you will see it's going through. So it's the bytes are getting received. But if you try to increase it by just 10 bytes, right? So let me put 80. It won't go through. So it will say that the message is too long, right? So if your application doesn't know the interface's MTU size, or if there is in between there is some tunneling is involved, then you might see these kind of things when you're debugging it, but you might not, your application might not be aware of it. So whatever application sends, it thinks it sends the packet, but end of the day what will happen is like the other device on the tunneling side, whatever it is there, it will just drop the packet silently without sending you back anything. So this is something that I personally believe the developers has to know about it these days, like especially when you're working with all these VPN, like when you're in a corporate environment, you'll be behind a VPN or a firewall. So when you're running an application, like let's say you're deploying an application into your customer's environment where they have a firewall or a VPN network already available, right? So in that situation, these kind of issues might occur. So you can add it to your troubleshooting checklist or whatever, right? So this will help you in some of the cases where you will need to troubleshoot. Yeah, so I will go back to this.
Gautham, I have a question on that.
Yeah.
Again, it's a loop question.
Yeah.
That for the interfaces, there is a fixed MTU size, right, which we can't increase. Only on the application end we can
Correct.
increase how much packets are getting
Correct.
transferred, right? Is it like underlying instance type, it would vary? What is the maximum? Again, I don't know if like I'm deploying EC2 instances,
Yeah,
different
yeah.
kinds of type and
Yeah.
everything. Is it like this MTU size would vary between the instances, or it is like EN0 or something that interface is fixed across?
No, it is not fixed at the time, but most of the time the generic value is 1500 units. But let's say when you have a 10 gig connection, like most of the time you will get a 1 gig connection, right? So when you get a 10 gig connection, probably this value would be reduced, but actually you will optimize it for that. Like let's say you here basically like Acceldata, what we have is like we have our own data center. So within the data center, when let's say you have a VM running in a bare metal machine, and then you will migrate that VM into another machine for some reason, right? So when you're migrating, if it is 1500 units, it will be really, really slow. So since it is within the data center, what we do is like we will increase the interfaces MTU. So we will call it as something called as jumbo frames. So basically we increase the frame size. So the massive data movement, right, between the machines will be really, really high. So it is increasable. It depends on the underlying hardware that you have, and also it is optimizable. But generic value is 1500 for most of the times, like laptops and maybe EC2. I haven't noticed much on the EC2 machines yet, but most of the times it will be similar. But we can inspect it and we can see it. The trouble or the issue most probably will come. See, we don't need to optimize our application for these things, because whenever you attach your application to a particular interface, right, the application will be aware of it. So it will automatically figure it out. But the problem will come when you have multiple tunneling in between these interfaces. Let's say you have a VPN, or let's say you have a firewall, maybe their MTU size is less, right? Your application doesn't know about it. Your application know only the immediate interface size, right? So it will try to optimize it for that. But in between, if there is a hardware, so there is an optimal way actually. So what will happen is like that hardware which is having a less MTU will actually reply back to this device saying that, hey, my MTU size is less, can you refragment it? But what will happen is like it will send using an ICMP signal, ICMP protocol. But as I was telling, right, so ICMP is something that most of the time is disabled in firewall and VPNs, because people can ping and then they can see whether some device is alive or not. So because of that reason, silently that ICMP packets will be dropped by the devices. So in that case, whatever this guy is sending back, saying that I need a refragmentation, that message is not received at all. So your packets will be silently dropped, which you don't know what exactly is going on. So at that time, this is something that you have to check with your network team, or you can inspect it from your infrastructure side to get some understanding on that. So yeah, let's continue here. So again, this connection tuple, we saw this, and now let's see these four things, right? So this is just for the theory part, right? So what actually is a server and what is a client and what is egress and ingress, we will just discuss that. So a server is something that will listen on a particular port and respond back something that if some client is trying to make a connection, right? And client is something that who initiate a connection in the first frame. So server will never initiate a connection, right? So a client will always initiate a connection. That is how we differentiate between that. Like any element that makes the first initial communication channel, so that becomes a client, and then the server will be the response party. And egress, right? So egress and ingress, again egress is something that traffic that is going outside your network is called as egress, and a traffic that is coming inside your network is ingress. And there is a catch here. So this transaction of egress and ingress, right, we will define it by who initiates the transaction first. So for example, your client, when it let's say your client is sitting inside a VPN and then it is trying to connect to google.com or something. So now when your client is making a call, it is making an egress because it's going out of your network. So when it reaches the google.com will actually reply back. For your request, it will respond back, right? Your response will come back to your client, but that is not ingress again. So it is a single transaction. Basically, like you make an egress, which is a request, and the response will come back via the same channel. So both of them together, it forms a single transaction. So basically, we can have a analogy like a shopkeeper, or if you go to a supermarket or something like that, you give them some bill amount, and then they will give you back some change, right, balance. So both you give and then whatever they give back is a single transaction. So we call that a single transaction as an egress only. So ingress will occur only when, from the server's perspective, let's say a server is sitting behind a firewall or VPN or something like that. When somebody is sending a request inside, let's say the client is sending a request inside that server. So at that time, from the server's perspective, it is called as an ingress. But again, the ingress will have a request and then the response will be sent back via the same ingress. It's not going to be an egress because since it is not going through a separate initiation. Somebody initiated it and we are just responding it back. So it's called as a single transaction. So this I've seen many people get confused, like especially when it comes to firewall rules and all. They think, okay, maybe the server has to respond back. Now that is called as an egress again. It won't be like that. So ports, right? So when it comes to ports, we have this port ranges from 0 to 65,535 ports are there. In general, like in Linux machine, that is how we have the range. And this 0, right? The port number 0 is a very special number. Actually, no software will try to bind to 0. You cannot bind to 0 because 0 is a special number. When you ask your software to bind to 0, right? Basically, what that means is like your kernel. Your Linux kernel will try to allocate a port which is available right now, a random port. It will just give you that port. Basically, no software can bind to 0, and that is a special port number. And from 1 onwards till 1024, it is a registered, registered restricted port number. So when your software try to attach to any of these ports which is less than 1024, you have to be root. Or what you can do is like in this modern Docker related, container related interfaces, right? So what will happen is like people will give capabilities. So for your container, you can actually give a capability that will make sure that you can attach to a port which is less than 1024 without the root user. So if you try to run a container and then if you try to attach that container to port 80 or port 443, you will usually get an error if you are not your root user. And to avoid that, what you can do is like in your YAML file or even in your command line when you are running it, you will add some capabilities that allow this software to attach to this privileged ports. So that is something. And then again from 1025 to till 49,000 some range is there. So till that it is again reserved for all these software, well-known software vendors and all. So basically like any software can use it, and also there are some ports which is like well-known ports are registered by some famous softwares, like let's say Redis will have a particular port and MySQL will have a particular port, right? So they have their own registered port numbers, and also the range can go up until 49,000-ish, where your software can attach and all those things, like when you are running a server. And again, ports are something like when, let's say there are two machines where you have your client and where you have your server. when your client is making a call to your server, right? So server has a port number 80 or something like that. So client also, wherever the client is running, in that machine also some port has to be open, because any incoming or outgoing needs to go through a port. So let's say you go through a port, and then like let's say for that those kind of ports, right? Those kind of ports are called as ephemeral ports. So that again ranges from that 49,000 to till that 65,535, till that it is called as an ephemeral port. So these ephemeral ports are automatically assigned, and then once the purpose is done, it will be reclaimed back by the OS, and then whenever another software runs for the ephemeral port, it will just assign it back. So when your client runs, it will get an ephemeral port to make a connection to outside, and in your server it is already bound to a particular port, which is a well-known port, and then once it receives it, it will send back the request response back. It will go through the same ephemeral port and it will reach the client. As soon as it reaches the client can actually decide to close the port, or it can do a keep alive or something like that. So it can keep the port open, and then it can keep the connection alive for some more time as it requires. So yeah, so mostly that is it about the port ranges. Yeah.
Egress is via ephemeral ports.
Egress is via ephemeral ports, but you can actually force your application to use a different port also.
Oh.
So these are all like by default whatever the OS provides is that ephemeral port thing. But actually when you're writing your client, you can actually, there are some adapters which you can attach. You can actually force it to use a particular port also. You can force it to use 80 also to go through. But again, privileges and things will be there. So you can customize that as well. And
From the client side, there will be ephemeral port which will be used for initiating the connection at the server end,
right.
So the egress would say Google is going 443. So on the firewall side, it only matters whether the 443 is allowed for the outside call. And you mentioned that when the server responds back, it will be on the same
Yeah,
channel.
yeah.
So that time firewall and other stuff doesn't matter.
Correct, correct. Let's say you have a firewall and your firewall is allowed only for egress, no ingress is allowed. So in that case also, when you try to run your google.com or something, when you try to curl or ping google.com, right? So you will be able to send a request and Google can able to send a response back as well, even though you don't have an ingress allowed thing. The reason is it will use the same channel. It's a single transaction altogether. So let's say, so for that there is a catch also, like the ephemeral ports, right? The ephemeral port range that I said, like 49,000 to 65,000. That ephemeral port has to be allowed to come ingress, because ephemeral port is the one which is making a call, right? It should come back. Like if you have a the firewall has multiple types, right? So there is a firewall type called as state firewalls. So if you have a state firewall, you will have to mention this ephemeral port as an incoming ingress allowed port, or else your outgoing connection won't work. Even though you have full outgoing connection allowed, the other server cannot respond back to your ephemeral port if you don't have an ingress allowed for your ephemeral ports.
So that we will specify that ephemeral port range.
Correct. So in your firewall, you will have to mention that only for the state firewalls. If you have a dynamic firewall, then it doesn't matter. It will work as usual. So yeah. So a listener is basically the software or the application which is attaching to the port. The listener doesn't really need to be a server or an application. It can just listen on a port, and then whatever data is coming to that port, it can just put it into your backend. So that is your listener part. And socket is basically that file, this file connection tuple, right? So this is called as a socket basically. So along with your port and your source IP, source port, destination IP, destination port, these 5 elements together called as a socket, and which is uniquely identifiable, element in your OS. Yeah. So when you write a Go, specifically we'll talk about Go here, right? So when you write your Go HTTP server, so these 4 timeouts are really important. Like we will need to take care of these, and by default these timeouts are set to default for forever. Like they will wait forever. Like these timeouts are not actually set, right? So these timeouts we will have to take care whenever you're writing a server. When we start coding, right? So we will get to know about these elements. And this is client configuration. So in your client, these are all the important configurations about specifically related to timeouts and request and response. These 5 configurations are really important. So this I'll explain it. So this read timeout is basically like your server is waiting on a port and a client is sending a request, right? So to read the entire request, how much time it takes, right? That is your read timeout. So let's say you set your read timeout as 1 second, and if your client is sending a big JSON or an XML or something like that, like some few couple of MBs or something like that, then if it couldn't read it in a minute due to some server busyness or something like that, then this read timeout will kick in. And read header timeout is specifically for reading the headers. So read timeout actually includes the read header timeout. You can actually segregate, and then you can specifically maintain a read header timeout as well, because there are some security attacks, like security attacks that people can do just by bombarding a huge amount of headers, by not sending any data. So at that time your server might hang, or maybe your server might waste a lot of resources. So to avoid that, you can actually use this read header timeout configuration as well. And write timeout works in two different ways. So first thing is, like, let's say your server, whenever it has a request, your server will have to go into the backend, and then it has to do some work, right? Let's say it has to query a database, or it has to connect to a particular microservice, get the response, do some computation, and then respond it back, right? So this whole time, whatever it is doing, so that is your write timeout thing. So your write timeout is like how much time your server should actually wait for your handler to respond back. So let's say you have a benchmarking that my server will always respond back in maximum 30 seconds, depending even whatever load it has right now. So if you set write timeout as 30 seconds, if your database or if your other service is taking more time than this 30 seconds, this write timeout will kick in, and then your server will close the response. So it will not send anything back. So this is required, because if you don't do this, right, your server will infinitely wait for your backend to respond back. So basically the client who made the connection will also be infinitely be waiting. So for that, to avoid that, you will have to set a sane write timeout value here. And idle timeout is like your clients, right? So you'll have your clients will have multiple connections open, like multiple concurrent connections open to the server, and then when they have enabled keep alive, so your whatever connection it has opened, they will keep it alive for certain time. So if your client may be forever, it can, so if you're running a server and the clients are ran by your customers or something like that, so they can decide to do the keep alive forever. Let's say 1 year, 2 years, they can do that. But you don't have the resources to keep the connection open for like that many time, right? That much of days. So what you can do is you can limit yourself by setting this idle timeout, so that you will your server will have always free the resources when it actually done.
So this idle timeout
Yeah.
is a combination of read and write plus.
No. This idle timeout is something like your client is not doing any operation, but it just makes the keep alive connection. Like once, like let's say you make a call to your server, and as soon as your response came back, the client can decide to close the connection because it got the response, or it can keep the connection alive, and subsequent connections it don't need to open it again. It can just reuse the same thing. So that is called as an idle connection. Until the next request comes in, it will keep the connection open. Let's say if the client decides to open it for like forever or even 30 days or something like that, we don't want that, because our server will get busy if so many clients have been decided to keep for 30 days or something. So we will make sure that it is getting timed out in like maybe a minute or 2 minutes or something like that. So when the client tries to make another call, it will have an error saying that the connection is already closed. So it will actually redial, and then it will make a new call. So this is for that on the server side.
Making a connection is expensive also.
Correct. That is why they allow keep alives.
Okay.
So they will keep the keep alives, and then they will have connection pools. Like Postgres and all, if you see, there is a lot of connection pools they will open. So this idle timeout is related to that connection pool. Yeah. And on the client side, we have dial timeout, we have client timeout, and then idle connection related configurations. So dial timeout is basically before reaching the application, right? So whether the client is able to connect to the port or not. Let's say your server is not reachable, maybe a DNS problem, or maybe in between your IP hops there is a problem in between. So your packets are getting dropped. So at that time, this dial timeout will kick in. So basically, dial timeout doesn't really do a lot with application. It has something to do with your infrastructure and the accessibility. Like you have a firewall, or you have some other latency between your connectivity wiring and all. So that time, this dial timeout will kick in. And client timeout is basically the time the client will wait for the write to come back. So here in the server, we have a write timeout, right? So write timeout, when I was talking about write timeout, I told about there are two ways write timeout will come in. The first way is your handler, when your handler or your database or your internal service, backend service will take time to write back, so this will kick in. The second scenario for the write timeout is, let's say your client is really slow. It asks for some 5GB file, but it is very slowly writing. Maybe your disk is not NVMe or it's a normal rotating disk or something. So it will write like few bytes per second or something like that. 5GB, it cannot, the server has to keep the connection open, keep pushing it, right? So at that time, if your write timeout kicks in, and along the way, if it gets a cutoff, your client is really slow, so your write timeout will also occur over there. Even though your backend is finished fast, the client who's receiving the data is really slow. So at that time also write timeout will kick in. So yeah, that is on the client timeout side. And your max idle connection is like how many connections, this is for the optimization of the performance that you said. Opening a new connection is always expensive, so you can actually set up like how many idle connections your client can have in total. And again, this is like per host. Let's say your client will connect to multiple hosts. You can say per host how many, and then you can say in total how many. So basically this has to be really high than this because this is per host, and that is like total number of things including all hosts together. And idle connection timeout is basically in your client side also you can decide how long your idle connection can timeout, because your server can keep the client side, it can keep the connection always open. Let's say your client will connect to 5 different servers. So one of the server is always keep the connection open. So if you try to make new calls for that, then you will eventually have a stack of idle connections from your server which is not giving up yet. So at that time what you can do is like you can do a disconnect from your client side also. So this is your client idle timeout. So basically most of the time when we have this network issue or timeout issues, these are all the configurations that comes into picture from servers and client side.
I have a question.
Yeah.
When we keep the connection open, is there a possibility, I mean, though let's say it's via like HTTPS connection, so I've opened a connection. Is there a possibility if I keep the connection open for long, can there be an attack like a cybersecurity or something like that? Can someone use this connection from an external?
No. Your so this tuple we saw, right? This connection tuple. So actually, connection tuple will have your IP and your port. So this become unique, right? So nobody else can interpret or something like that. That is not logically possible.
Okay.
So
client timeout, right?
Yeah.
If server is taking a long time to respond, client itself can close the connection.
Correct. So that is on your client timeout part. Correct. So let's say your server is taking very long time and you don't want to wait for that much time. You can also optimize it from your client side. So when you write at your work, right? When you write both server and client, like when you have ownership on both of the things, these things can really work out very well. You can actually optimize it. You can have a very good compatibility between your server and client. But sometimes what will happen is like server will be handled by a provider, and we will be only writing the client. At that time, what max we can do is like only optimize it via this, and then see how well we can perform within these options. And certain times what will happen is like we will control the server, and our customers or some public can connect to our client. So at that time, you will use that server side things to make sure that you avoid all these issues, or provide as much as information as possible upfront to the whoever trying to connect or whoever trying to access, so that they can correct themselves from their side.
This is only at the client side, or any network hops we get, they also have some kind of timeouts?
So let's say this firewall or these modems will be there, right? Like that, there are many network devices are there. In between that also, they can have, most of the time they will have a generous amount of time, but they can have some kind of a problem over there. But the timeouts really doesn't matter. Either you will pass the packet or you will drop a packet. So it will be mostly like that. Timeouts and all very rarely occurs in general network.
Gowtham also, again, sorry to go back, talking about the ephemeral ports and stuff.
Yeah.
If there is a NAT in between, between the
Huh.
and the server.
Right.
So how that dynamic changes, whether NAT
So yeah, so yeah, that is a good question, right? So when we go here, right, let's say this is my laptop. I'm making a call, and then it has this ephemeral port, it goes to this IP and this port, right? This is, let's say this is google.com's IP and then this is 443 I'm connecting. So this is my laptop's IP. You can see it's a private IP, right? But now we have connected to Wi-Fi. This Wi-Fi will have a public IP. So NAT, what will do is like this, whatever modem or router that we have, it will actually have its own table where it will map this laptop's IP address into the public IP address, and it will have its own ephemeral port. Yeah, NAT will happen. Basically, like it will allocate one more ephemeral port over there. So it depends on the configuration. Sometimes the ephemeral port will be exactly same as whatever is available here, if you see the other way. But sometimes it will allocate a different port also. Like from your public IP, ephemeral port will be different. Like when you from source server, right? In server side, if we look at the request, like request whatever is coming in, right? So if we check this tuple, you will have a public IP and the ephemeral port over there. But when you check the tuple in your laptop, when you are inspecting that, you will see your local IP and the ephemeral port over there. So this is actually a good comment, right? So we also had similar issues, right? So let's say you do some kind of a tracing or logging. When you add this tuple into your logging or tracing place, but when you in the server side, when you do the tracing, the tuple will be completely different. Here it is different, there it will be different because of that natting happening, right? It will be because of that it will be different. So you will have to have a, that is why in the modern tracing and all, if you see Jaeger and all, they will generate a unique string and then they will pass on to the headers. So that is the way to track it. If we use connection tuple to track, then it might not work out well because if you have a NAT in between. So that is a good point. Actually, we also faced that thing in the initial day, and then we have corrected it using Jaeger related, like unique identifier we were generating. We can take if we can take. Yeah, we can take.
And then an hour later you want to take another 10 minutes?
Yeah, sure. Cool. There is coffee available there.
Biscuits there and the toilets are this side.
Yeah, this side. Yeah. You can come this way. This way. There is no way there.
We'll start in 10 minutes.
Yeah, sure. No problem.
Okay. Do you want to take another 10-minute break after 1 hour?
Yeah, there will be coding right now. So after that, we'll take 10-minute break, and then there will be one more coding, and that's it.
Just one request, if you can repeat the question that they've asked for the live stream audience.
Sure. Okay.
I mean, not the entire, but you can summarize the question.
Okay.
Yeah.
Okay, got it. Should we do something on the YouTube side to make it?
No, I have already informed them.
Okay.
Yeah,
Okay.
we are fine.
Hi. எப்படி இருக்கீங்க? போயிட்டு இருக்கு. இது கொடுத்துட்டு வந்துடுறேன். Should I remove this?
Yeah, you can remove it and keep it here and then when you're back.
Okay. Yeah, I have it in the thing. I'll share it in some
You
place.
can post it in WhatsApp group as well because I think it's not been posted, the resources.
Right, but let me see how to put it high. So I have it here. It's a public repo. Can you guys just go and search for it, like, or is there a common place I can put in? I'll do a short URL or something.
I think you can put it in the Hasgeek.
So I need to share this with the people. How do we generally do
We
it?
can put it in the WhatsApp group and then I can
Yeah.
also put it in the
Okay.
Facebook page.
WhatsApp. I'll just search then. Yeah, I think I get it. I'll just share it.
Shall I put it? I have the link.
Yeah, you can put it if you already got it. I also got it.
Yeah, I just posted in the WhatsApp group.
Okay. So you can just clone this and then clone it to your laptop, and then we can just continue from there.
This batch is mostly long. From now to Chandra and Gowtham.
No, no, no. This is
Charging. I think we have to probably spray USB cable or something.
No, it's focusing on that. It's okay. Welcome down.
Huh. Oh, it went down. Okay.
Just see.
Done.
Can you just move on? Wait. No?
Ah, okay. Okay. It's moving. It's moving. The mic is also working, right?
Yeah, mic is, I think, is fine.
Okay.
Mic is fine.
Because I removed it and then put it back. Should
Yes.
be fine, right?
No,
Okay. 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 So we'll start with a small server code, right? In general, how do we write a small server code without much of complications, right? So yeah. close this guy. Looks good? Everyone can see? Okay.
Yeah.
Listen and serve. So here we will have a HTTP handler func. So you can see this is as small as possible one server. So basically this will listen at port 8080, and whenever a request comes, this handler func will respond back saying that this will send a header saying that 200 HTTP code, and then it will just write back hello world. So this is like as simple as a small server that we can get. Let's just run it and see how it goes. Where do I? Just run it from here. So now it is running. Now if I go back here and do .080. You can see hello world came, and then you can see 200 received 200, and then some default headers it is sending, and we see hello world is getting printed. So basically this server responded to this thing. This is like as small minimal server as what you can get. Yeah. So now let's try to extend it a bit. Right. So this maybe you can follow or you can just watch this, because in the server code that I have shared, it has some advanced stuff. So I just wanted to build the base from here. So you can see we evolve, we move away from the smallest one. So here you can see you don't have a lot of configurations. The timeout and all those things are not there available yet. So we will just slowly decouple this, and then we'll add some more configuration so that we can see we will have a control over this server on the timeouts and other configurations.
Is there any default header is available? We don't specify the status of it. Like, is there any default lost on the right header?
You can just do that directly. You can just do a header thing, like let's say here 200 is coming, right? You can actually directly type that number also. That also works, but yeah, this is like a minimal thing. Like whatever comes, like you don't make any mistakes from that, right? So because here, right, all the numbers are defined already, so you can just go there and then all the status codes are already defined. You don't need to specifically mention a particular number or something. So yeah, let's try to extend this. Now when we talked about that components, right, we talked about port numbers, we talked about listener, we talked about a socket, right. So now let's this is a handler and a listen and serve. So both of them are combined together in a single function. So what we can do is like we can try to move this handler out. Oh man, my cursor is doing its work. Okay. Handler func, yeah. So I moved the handler and then I put the handler here. It's just a handler move, and then now what we'll do is like we'll remove this listener as well. So we will have our own listener. So we can have listen, and we will have to defer and then here we don't need to do that. So now if you see, right, so we have extended that a bit. Now we specifically mention it's a TCP. We don't need HTTP. I mean, we are not specifically going for HTTP now. Now we have one layer down. We are at TCP. So let's say you have a custom protocol or gRPC or anything like that. So you can just listen it on this way. So it is not explicitly now meant for HTTP. The client can understand it on its own. So port 8080 we have put. So we have our own custom listener, and then we have our handler, and then we will put it into this serve function. So now this will exactly work the same way how it was working for the other one. So rerun it. You can see the result is exactly the same. But you can see we have more control because more control and more configurations are available, because we have separated things out, and then we have a listener. So if you look at it, right, this is what I was telling when I was talking about listener. A listener is just a program that listens in a port. It doesn't do anything else. The actual functionality, actual thing is done by this handler. Handler is your actual application. This listener is just to listen on the port, and whatever comes into this port, it will just put it into the handler, and handler will take care of it. Now we will go into that advanced configuration part. So once we finish this, you can just follow it on the code base, because it will be the similar thing. But until then, you can just have a look here. So now we will define our server, HTTP server. I will not do this because we already have those things mentioned here. So we will just directly go ahead with our configuration that we wanted. So this is like read timeout. You can see, right, it's getting written. So now we will do the read header timeout also. So everything is set to 1 minute. And in the handler function, now we can, now this is like regardless of whatever request is going to whichever path it is, it will get triggered, whether it is slash or slash demo or slash new or something. So now when we wanted to handle the path, right, so now you will do a handle function. So you will go for a handle, and then you will do this. So now what will you have is like you have this slash. So whoever comes to the root, they will get this function executed. So just so many things. What I will do is like I will try to print all the things that we wanted. Handler. Print timeout values, so that we can see what timeout that we have set and what's going on, we can see it. So this slog, right, so slog is a structured log default library. So now you don't need to use any zap or any external library. So Go itself has its slog. It has minimal functionality that we require, and it is good enough for any minimal programs that we have. So we don't need any third party library. So this is something that we can use for printing our values. So now we have our listener port on 8080, and here, right, so instead of in the serve, we will have this ln, because we already have that thing attached, right. So you can see it is attached to the HTTP. So we will not need this anymore, because it's not a handler function anymore. And you can see the server that we have created, it has these configurations, and then we are adding a handle function to this HTTP, and we are giving this listener, we are creating a listener, and then we are giving the listener back to the serve function, which is from this server. So this will also exactly work the same way how we have, but it has a much better control on the timeout side. You can see the timeouts are set as 1 second for almost all of them. Now let's try to run it and then see how it goes. So it printed that timeout values. Yeah, so it works exactly the same thing how it worked earlier. You can see. So now we have defined from the simple server, we have decoupled things, and then we have reached here where we can have control on our timeouts. Yeah, so from this point onwards, actually you can follow from the code base that we have shared. So I'll also open that code base. So we will start with the server. Just that I added logger related information over there. We can just compress it for now. We can read. It's a very simple thing. We can read about it a little bit later also. We'll come back to the logging part later. But forget about this part and then you think about the rest of the things. It is exactly the same as what we did right now in our from scratch whatever we did. It is exactly the same. You can see I added some more these things, and then listener, I removed the listener because it's not helping us much. So instead what I do is like I did a listen and serve at the bottom here, you can see, and then instead of listener I am adding the address directly into the server. So little bit of configuration change, but it will provide the exact same thing that we have.
So we are starting a server with our own custom configurations.
With
overriding the defaults.
Yeah, so defaults are generally 0. Okay. So basically they just hung or they just wait forever. And now we have a sane value that now we know for our application and for our latency how long should we wait and how long when we should give up. Most of the times when we start our application development, right, this will be a trial and error. We'll just go with some sane values what we think is right, and then over a period of time when the number of requests grows or when our scale grows, right, then these changes will keep on coming in. So basically you will make this configurable, make it like an environment variable or something like that, or in your config file, and then you will keep it up to date depending on your use case and the environment and the traffic that comes into your server.
Are there some metrics where we can check the P99 values and based on that we can set this as?
You will have to set up that, maybe a Prometheus exporter or something like that. You will have to add it, and then that values you can use it to determine these thing. You can come up with that after things. For development purpose, where you can just start with it and then you can go ahead with it. But when you add a Prometheus metrics, then probably you will get those things metrics. But actually, that is the right way to calculate. Yeah. So now this is our server. It will exactly run the same way, but it's just that I added some logging part here. So you can see, right, slog. So what I did is like from environment variable, I can set the log level. So for that, this function is being used, and then from the environment variable, I can set the log format. By default, I will be printing in JSON, and then if I don't want JSON, the other format supported is text. It will be a single line text that will be printed over there. So for those two purposes, these two functions are there. Pretty simple, straightforward functions. Here I am initiating the logger, and then I am calling this in the main function. That is it. So once you have that, so whenever you have this slog info or whatever, depending on the log level that you are mentioning, it will get printed accordingly, whatever your log level that you have set. So that is all I have added compared to what we built right now. So I just added these few things, and now let's go for the client. So now I was using client as a curl, right? Now we will have our own client as well here. So client also, if you see, so client also, if you see, same thing. I have initiated the logger, reading the log level from here. We can actually move all these things into a library and then we can call it as well. But just for simplicity and reading purposes, I just added it everywhere so that you can just see where exactly I am adding. So you can see these 5 configurations that we discussed about the client. I have added them here. And client is pretty simple, right? You have a HTTP client and you have a dialer. So dialer will have a dialer timeout, and client will have the client timeout. And transportation layer will contain this idle connection and all those things. So it's all just pretty basic print statements that I have, and you can see here using the client which we have created here. We are creating a HTTP client here, and then we are using the client to make a request to this particular server, because my server is running on 8080, so we are just making a connection to there, and when it fails, we fail, and then we defer the connection close, body close, and then we'll try to read all the response that comes from the server, and then we print it back. So just see in your laptop you are able to run these code as well, the server and the client. So we can build on top of it for the other configurations and things. Go run.
So defer, that is basically closing the connection.
So defer will kick in once your program, once your function is at the end, right? When your function is completely closing, defer will kick in automatically. Let's say you want to do some cleanup, you wanted to automatically close something, you wanted to take care of some kind of a cleaning and all, you will put it in a defer function. So when the program executes the function completely, when it is closing the function, then at the end it will execute that whatever you defined in the defer.
So the place where it is written doesn't matter.
Usually, if you don't want to forget what you are doing, you will write it in the top itself. As soon as you do something, you want to do some cleanup, people will write it immediately at that level itself.
Oh, I mean,
But the execution, the line doesn't really matter, because that will get executed only when the program is ending. If you have multiple defer statements, it will get executed in the reverse order.
I mean, it reminds me of this try, catch, and finally blocks in Java.
It is something similar, but it is not exactly that. Go doesn't have a thing. Go has only error recovery function. So there is a recovery function is there. Like let's say your program is crashing, it can recover from that crash. It can do that, but there is no try catch mechanism in this. But defer is something like whenever you want to do some cleanup, you keep adding the defer to it. Let's say you have more than one defer lines added to your function, it will get executed in the reverse order. Not the first defer will execute in the last order. Whatever you execute at the bottom will be executed in the first.
Oh.
So it will execute in the reverse order.
Okay.
So now I am running the server. So you can see request failed, EOF came. Probably because of one of our configurations.
The read header timeout is set to like 1 nanosecond.
Correct. So probably because of that our configuration, we can just go and modify that. This is on the client. Server. Yeah. So this is why that error is happening, right? So which you have pointed out. Now we can just change it to second. Yeah, 200, hello after a delay. Now it got printed correctly.
But how do we debug at the client side that this is what is causing from the output? Like you do curl.
Correct.
How do we actually understand what is the cause of
We'll do that. So we have that exercises directory, right? There I have all the scenarios that, so total 4 configurations we have on the server side. In the client side we have 2 configurations, total 8 configurations are there. So there are 8 exercises are there. We can execute one by one and we can fix it. So by the end of the exercise we will know what exactly is causing the problem.
Do you have some limit? Let's say here the read header timeout is happening.
Yeah.
So server is not actually logging that, it has hit the timeout to read the header.
So the response, right, the EOF comes, right? EOF usually comes when the read timeout kicks in. Either EOF will come or connection reset peer. Connection reset by a peer. That message will come. Either one of that will come. So now let's now say, like any questions on the server and client configuration?
I have a question on the connection reset by peer
Huh.
versus EOF. Is there any specific meaning attached to it? Like connection reset by peer means the server abruptly can do that?
Correct.
Kind of.
Correct. So let's see if you have any questions on this code. Do you guys read this code? Like, did you read this code? Like, server and client, both the code you are able to understand what we are doing? Pretty straightforward code, right? But the configuration part is the thing that we'll need to focus on right now, right? So now we'll go into the exercises part. So if you open the first exercise, right? So here what I did is like intentionally there is no server here. So the dial timeout thing only kick in, actually there is no server that is listening, or there is no way that you can access the thing. So let's run that and then see what happens. So there is no server running here, right? I just print some statement. Now if you try to run the client for that, you will see this, right? Dial TCP lookup. So this usually kicks in only when you don't, your server is either not running or it's unable to even reach that port or reach that IP. So either one of the cases you will see this dial TCP or your firewall is blocking it. So no way to reach the server or IP or its port itself, then this error will come. So this gets an idea, right? Now when this kind of error comes, that means it's unable to reach at all.
Is the connection refused? Or
No, it's not like you're unable to even reach that port number. DNS or even the port or your firewall, either one of it can cause this. So basically the dialer will try to connect, and since there is nothing running over there, your dialer is basically timing out. So this actually kicks in because of your dialer timeout. So dialer is the imagine so the proper thing is like the old telephones you see, right? There's a dialer. So it is like that. So you put the IP address, you put the port number, and then you send it. So that's your dialer.
it's like we are trying to reach
Reach something.
not available.
Exactly. We are trying to reach a number which is not even available on the other side. So that is when you get this. So you can take the analogy in that way, so you can easily remember that. So now the dialer timeout kicks off because of this. You see this, right? I have this 500 nanosecond for the dialer timeout. So quickly it came. So if we increase this to like 1 minute or something like that, till 1 minute this guy will wait, and then he will still fail with the same error saying that it was unable to connect because I am not running a server anymore. There is no server running here, right, in my terminal. It will hang. It will hang. Our default some OS, depending on that OS, whatever we are, maybe Mac can have some impose on that. Maybe it can do something about it, something like that. The default value, whatever is coming out, will be given to that. Most of the time, the default value in Go is 0. So it will just wait forever, or maybe it will wait for more than that we wanted. Maybe it will wait for 3 minutes. We really don't want to wait for 3 minutes because those many times if we wait, right, if so many connections are there, so our entire server will be filled with only waiting time. We will not make any progress over there, right? Especially when it comes to Go, right, we have that philosophy of fail early mechanism, right? That's why we do that error handling and then quickly fail. So whenever this kind of issue comes, we should fail quickly. Unless there is a scenario that we really wanted to wait or maybe retry or something like that, we should actually fail quick. Correct. So those kind of issue, if you don't want, this is the way to handle it. So you put the dialer timeout, then it will not hang.
The one quick, so let's say if you have increased the dial timeout as like let's say 3 seconds. When the client, this module gets executed, server is not yet started. But now I start the server after it tries.
It won't work. Still it won't work.
So it's not a wait actually happening.
It already mailed a dial.
Okay.
So once you make a dial, like same like phone call, once you already dialed in, if now the phone comes back, it cannot reach anyway, because you're already dialed in a dead loop. In a dead wire, your connection is already in a dead wire. It is something like that. So yeah, now this is done, and now let's go back to this exercise 2. So I am running a server here. And now let's run the client for this. So this you see this, right? Connection reset by peer. This error comes, right? So whenever this error comes, basically you can see this is this can happen either on the read side. Let's say the total body is not read by the server completely, or the header also, because the header, the read timeout is inclusion of the header thing, right? So now what I did is like in the server side, I actually reduced the header read timeout to very less time. So if you go to the second exercise, server, so you can see read header I put 1 nanosecond. So basically your header is not like the client sent a header, but this guy wants the header very quick, like in 1 nanosecond. Obviously it is not possible, so he will close the connection immediately. So on the client side you will get reset by the peer.
Will it send back different response codes and stuff to determine that this is what is happening?
See, the point is it is not even reached the protocol yet. It is on the let's see. This is server side. Server side, if you see, right, there is nothing much change here. So I have given 10 seconds for this, 50 milliseconds. So this is all fine, right? So now in the client side, if you see, I have some bit of an extensive code here. So what I'm trying to do is like I'm trying to write this, okay, and this is the request I'm making. I'm trying to write this request, but what I'm doing is like I'm writing it with 1 byte like per 10 millisecond. So likewise I'm doing a loop here. So what I'm doing is I'm writing into the request, but like 10 bytes of that message. So by the time I try to write right there, I have a 50 millisecond timeout here. If you see, I have a 50 millisecond timeout. 50 millisecond is very small, but this guy will be writing it in a very slow way. So basically if you calculate, right, it is around it's around like 400 200 seconds or some 200 milliseconds or something like that it should come, this particular message. But I'm closing it within like 50 milliseconds. That's why it is going to fail. Let's run that and then we will see. Now you can see, right, write failed, byte index 6. So in between it is trying to read, the client is really slow, the server actually closed the connection in between. So that gives you a broken pipe error, because the client will try to write the things very, very slow, and then server says that I cannot wait more than 50 milliseconds. That we have it here.
So here is basically we establish the connection, but
Huh.
the actual payload is going very slowly.
The client is actually reading, the server also sends the has to send the response, right? So this guy server has to wait for the request, right? So when server is waiting for the request, the client is really, really slow that it is writing one byte to the server. Server cannot wait forever. Let's say this kind of things can be used to attack your server. If you don't properly maintain this configuration, right, I can run some 10,000 clients, and then I can start slowly sending one by one, byte by byte. So your server resources will be wasted by this thing. So actually this can do that service DDoS kind of attacks people can do with this attack. So it is really, really important that you handle this. When a client is very, very slow, that if you don't want to handle it, you should drop the connection. You should do a connection reset, or you should stop allowing it to read. So now how do we fix this, right? So if you go and change this configuration on the server side, instead of 50 milliseconds, delay. So let's say actually I need to fix it in the client, sorry. It's in the client. So here I am sleeping for this much time, right? So instead of sleeping for every byte, so 40 deadlines. Oh man, I should mirror this, I think. So you will wait for some 250 milliseconds. Server. Okay. Now also it failed, but the byte index is now 24. It has increased. You need to increase more. Let's say 5 seconds. You see? Now all bytes sent, waiting for response. So now the server is waiting for the whole time that this guy is trying to write. Close some of these old ones. This is on the 4th exercise. Here if you see, right, that read timeout, it just slows the body here, right? So read timeout is very less. You can see 50 milliseconds. On the client side, we are putting into a sleep with a delay. So it will be very slow when it is trying to send the request. So you can see, right, read timeout fire because of the reading the body is very slow. So within 50 milliseconds it has to completely read it, but since the client is sending it in a very slow way, it couldn't finish it by that time. So should we run all of them or should we continue with the next thing? So we have write timeout, client timeout, idle timeout, and client idle timeout. This above idle timeout is server idle timeout. Because I have all these exercises over there. Maybe you guys can try it yourself and then see how it goes. Like in the headers, right? In the headers of this comment itself, I would have mentioned like what exactly I am changing and how to fix the error. That is there in the comment section. You can just refer that as well.
Can we speak about the keep alive in one of this?
So this idle timeout, right? So if you go this idle timeout, this is server idle timeout thing. So if you see here, right, we keep the server idle timeout as 1 millisecond. Server idle timeout is 1 millisecond. So every 1 millisecond, the server will close any connection that is not doing any activity. So now on the client side, if you see, on the client side, if you see, we are using a transport. We are using a custom transport with a dialed context. So what we do is like every time when we make a call, right? Every time we make a call to a particular server, so we have that connection tuple, right? So since it's the same program, it will reuse the connection, and we have set that disable keep alive to false. That means keep alive is enabled. So when you in the transport layer, if you enable it, and then we say that this really doesn't matter for this particular scenario, you can even put 10 maximum and 10 per connection also. Still, it will throw the same error. It will come. Since we have enabled keep alive, every time I do a call, right? So here at the bottom, you will see I'm doing a get here. I'm reading the response. After 50 millisecond of sleep time, I'm doing another get here. So now generally, if you see, it will reuse the keep alive. But the server side, the idle timeout is 1 millisecond. So when as soon as the first one comes and it is sleeping for 50 millisecond, server will close the connection. Now this guy will try to dial one more time. He will get an error saying that your idle connection is already closed. He will actually make a new connection. So what will happen is when it making a new connection, I have a counter here. So this counter, basically this function will get executed one more time when you make another call. When you reuse the keep alive connection, this will never get executed. So your counter will remain 1. But now since we are keep alive is like keep alive is like gone, now it will dial again and your count will increase to 2. So that we can see here. And we can fix it also, like how to, if you change that from millisecond to something higher than that, right? So it will be have this. So now you can see, right, connection number 2, connection number 1. So actually my count has been increased. Why count is increased? Because the keep alive is closed. Now the simple way to validate, right? So now instead of in my server idle timeout thing, instead of this 1 millisecond timeout, I'm going to change it to second and I'll give 10 seconds. Now you will see, just check the output of the current one in the client side. You have seen that connection number 1, it is making hello, hello came, it read, and then it slept for 50 millisecond, and then it the counter increased because it is making a second request, and then the counter number 2, it came, and now you don't see this exact result. You should not see it. You will see the counter will be only 1, but it was able to reconnect. So now I'm going to restart the server with the newer idle timeout. So now you've seen this, right? Connection number is only 1, but you see it made 2 calls, hello, hello delay here and hello delay here, and after 50 milliseconds, because it reused the connection. And this is on the server side. Now we have discussed about the client side also, right? In client side also you can close the idle connection, because the server can also decide to keep the connection open. So that is under the exercise 8.
So who's actually taking the actual control of understanding this connection as idle? I mean, is it part of the Go, I mean the library which we are using?
No, it's underneath whatever TCP is there, right?
Okay.
That will decide whether a connection is active or not. Basically you have to make a connection every often. If you don't, like, imagine like again this is, you can use a terminology like a double-sided pipe. Whenever you make a connection, right, you open a pipe from this end to that end, and whether to pass something via the pipe or not is what actually the idle time mode connection thinks. So when you do a keep alive, you keep the pipe as long as you wanted, you're going to keep the pipe open. If you remove the keep alive, as soon as you send something and the response comes back, you remove the pipe, you destroy the pipe. So the analogy you can think of is like a pipe, double-sided pipe you can think of it. So now I have increased it, and then you saw that it got changed, right? Now on the 8th exercise, if you see now instead of server we have a client timeout. So you can see, right, idle connection timeout. But to have an idle connection timeout on the client side, it is not going to be straightforward. It is not going to be the same server configuration that we had. It won't work like that. You have to create your own dialer now. So you can see, right, I'm creating my own dialer, and then I'm trying to attach the I'll have a function here. You will have to attach it to this idle connection timeout on this side, right, on the client side. So once you have that, whether your server is still open it and your client will destroy, client will actually close it. Now we can run this and then we can see. I will show you the difference. So now you can see connection 1, connection 2. Basically client's idle connection was closed. You can see this message, right? That is coming because connection idle timeout is lower in the client side. Now we will just change that. In the client, instead of 10 milliseconds, you give 10 seconds. So once you do that, you will see the difference in the output itself. Here you can see, right, only one connection was there. And here you don't see this counter has increased. These are just print messages, ignore this for now, but you will see, right, that counter was not increased. The above one, if you see, you can see, right, total connection 2, counter number 2, counter number 1, and now when as soon as I increase the idle timeout on the client side, I don't see the counter getting increased. It reused that same connection one more time.
But if it is a slow client and server connection, like client has closed the connection,
Mm-hmm.
and if server is trying to send the bytes over the same thing, it will be broken, right, for it, the server.
Server will get to know that it is sending to a closed connection. Server will get the error.
There will be a server log.
There will be a server error saying that this pipe is closed. So basically, whenever you are sending something, so when we discussed about the egress and ingress, right, the transaction will be on the both the side. So as per HTTP, you can actually close the transaction as soon as one side is on. When we do the defer close, right, there is a mechanism that there is a defer half close also. So basically half close means I will send my request and then from my side I will close the connection. Now server can send me back, but I cannot continue to send. So I can close my side. So that is called half closing. So for performance improvements and certain optimization side, certain application will do that also. In a HTTP transaction, as soon as one side completes, it is still considered as a transaction complete only. The other guy can send it slowly, or other guy can drop it as well, because not every request needs a response. Sometimes we send a request that doesn't need a response. We just need to know whether it is 200 or not, like basically HTTP status code, but we don't need any body or something like that. Or sometimes we will even have something like in the 300 series that nothing has changed. I'll send back a message saying that nothing changed. So in that case, I don't need to do anything from my side. So for that kind of scenarios, we can use this kind of configurations.
Half close you mentioned for performance optimization.
Yeah.
What kind of performance improvements?
So you don't need to wait forever or something like that. You finish that and then you do your other work, right? Or else one of the connection that you have is still open. So you can quickly close it.
Or is it like async programming wherein you send out a
Correct.
request and whenever the full buffer is received or the
Huh.
response is received, you
Correct.
invoke a handle. And
Correct. And let's say one more scenario which I have faced personally, right? When you are running a lot of Go routines and all, right? If you have a lot of pipes open and these pipes are within a connection pool, right? And you don't want anybody else to reuse the connection again, so you close the connection. So nobody else will reuse the connection again. So that is one thing. Or else what will happen is like when you have a connection pool and in your Go routine, anybody can randomly pick a connection and then they will send it. So this will come when you actually write a muxer. Like in Nginx you will have a muxing thing, right? Like you have a star dot your domain name, but once you receive it, you will actually upstream will be different for each domain, subdomain. So something like that, if you write it in Go, for each one of your domain you will have a connection pool. So now when a request comes in, you will have to route it to the correct thing, right? So now if you have a common connection pool, somebody else's request will go to somebody else. So for that reasons, you can actually half close the connection. Whenever a request comes in or a response goes back, you can just close it on your end.
But when you close it, let's say the port allocated to that listener, right?
Huh.
That you half close, but server needs to send back, right? The connection needs
Port will not get closed. It's just the channel that is getting closed. Now you're making sure that no other your threads or Go routines or something like that cannot reuse that connection again.
But if it is a client, for example, curl.
Huh.
In the curl, let's say think of this as the forward channel is closed,
Right.
and the response, let's say whatever you implemented, right? Bytes are sending in a
Huh.
slow buffer, right, to the string.
Right.
If you implement that in a server side, you
Huh.
keep on sending the bytes slowly. The curl is actually gone, right? The client itself.
No. You're talking about the program getting closed. I'm not talking about program getting closed. I'm talking about just the connection getting closed. So program can still wait on the other end, waiting for a response, but he will make sure that he closes the connection that he has opened. So in that way, the resources that it is holding on one side can be dropped at some level. And then it is again a security mechanism. It's just that another thread or something like that in the same program will not reuse the pipe again.
Any idea how is this implemented at which layer it is implemented, or
It's on the TCP layer. It will be on the TCP layer. It is by the underlying library itself. It is there. We don't write anything on top of it. Yeah. So now we have this thing, right? Now we have we did all these exercises on a HTTP server, and we have these configurations. Now I think whenever you have, like, even when you talk to a Kubernetes cluster or something like that using your kubectl thing, right, you will see these kind of errors only most of the times. Connection reset by peer, or the read IO timeout or something like that. Now I think even that is written on Go. So it is exactly the same primitive as this. Now you will be able to make sense that whether it's your network might be slow, or you will know that your API server is slow, or your API server's timeout is bit different. You can actually tinker it depending on your client speed and all those things. So you can actually make it work. If it is a real network problem, then it's a different case. But actually you can now go and debug that, okay, this error came, so probably this configuration in my Go application needs to be changed. Right. So that, I think, that is what I wanted to clarify and cover. I think that I did. Any questions on that front? Like basically 4 configurations on the server side and 2 configurations on the client side. With the mixed combination, not every configuration change will affect every client, but there are certain combinations which will affect each other. So that combinations, if you know, you will be able to debug Go applications very easily. I'm pretty sure primitives are similar for other languages like Java and all, but maybe the configuration is a bit different. Here I can have a read timeout and read header timeout, write timeout and idle timeout. There in Java probably it is the primitive is bit different, but it will be the similar case. We'll move on to the next section. So next is that PKI part I wanted to cover, right? So, or do we guys want to take a break or something? Take a break? Okay. You guys want to take a break? No? We'll continue? Okay. Okay, then we'll continue then. We'll finish this theory part, and then before we go for coding, maybe we can take a break. So yeah, so public key infrastructure generally it's known as like PKI, right? So you guys have used HTTPS everywhere, right? You would have seen it in all the other, all your websites are now HTTPS, right? So basically HTTPS is like HTTP plus TLS becomes a HTTPS, right? So these are all the important elements when it comes to PKI infrastructure. We can dig deeper into that, but just understand these concepts and then we can go further into that, right? And now we'll start with this private or public certificate authority. So generally a certificate authority, it can be private or it can be public. So what I mean by public is like all these bigger companies like Google or GoDaddy, AWS. So they publish their own certificate, and why I call them as public authority is like their servers are available out public. Anybody can get a certificate, buy a certificate from them, and any client or server can connect to that server and validate whether the certificate is valid or not, or whether it is expired or not. All those things we can do. So that is basically a public certificate authority, and the big companies are there, right? So whenever you buy some certificate, even Let's Encrypt is free, but still it is a public certificate authority. So they are the one who will issue certificates to your clients and servers, which can be verified and validated online whenever we need. So private certificate authority is something that we run internally, maybe within an organization or something like that. It's not publicly accessible. So here at Acceldata, we run a private certificate authority for our SaaS. So any of our applications that communicate with each other will connect to this private certificate authority and ask for a certificate and a key, so that it can identify itself, and all other services will connect to this authority and then ask whether this certificate is valid or not, and all those things it will do. So much like deeper things we'll do one by one. So now we'll start with the root certificate, right? So it is a hierarchy basically. So when you see, I'll take a pen. Where is
The marker.
yeah, marker. Oh. So yeah, thank you. So now let's have this. Let's see the hierarchy, right? How this thing works. So there is a root. There is a root certificate authority. Basically, when I say certificate authority, it basically means there is a certificate and there is a private key. So this pair will be there always, right? So a root CA will have a certificate and a private key, right? And using a root certificate, we will actually sign multiple intermediate certificates or one or more intermediate certificates. Let's say we will call this as intermediate certificate, intermediate CA number 1, and let's say one more intermediate CA that we will create, intermediate CA 2. So basically this also has a certificate and a private key. Here this also will have certificate and a private key. So basically this cryptography mathematics, if you would know, right? So in the PKI infrastructure, the logic is like this: using a private key, you can actually decrypt whatever is encrypted using the public key, and also using a private key you can sign certificates, you can sign something. So that is what the purpose of your private key, and your public key is used to encrypt data, and to validate whether it is signed by some authority or not, you can use the public key. So for those two purposes, your public key is used and private key is used for this other purpose. So this is the hierarchy, and once you have this root certificate and intermediate certificate, using any of this intermediate certificate you can keep signing. You can say I will have a leaf certificate. So this is like leaf certificate and leaf private key. So you can have n number of certificates and key. So this is what end of the day clients will use, and servers will have a chain of these two certificates with them. So whenever somebody makes a call using this certificate and key, the server will have the certificate, only the certificate is needed, certificate of this root and intermediate, and they will be able to check whether this certificate is signed by intermediate or not, and this intermediate is signed by root or not. They will be able to check this chain. It is called chain of trust. They will be able to validate that entire thing. So that in a server, whenever you are connecting with a TLS server, this is exactly what going on behind. So you will have your root CA and intermediate certificate inside your certificate pool of your server, and whenever your client makes a connection with this leaf certificate and key, the server can validate whether this certificate is signed by the intermediate and root certificate or not. So that is the hierarchy part of it. So your server will have these two, and your client will have this one. And what is this OCSP, right? Let's say whenever we issue a certificate, every certificate has an expiry, right? Certificate will have a expiry and when it is valid and when it is not valid, right? So I'll just show you something here. So you can see right here there is an issued on and there is an expiry, right? So let's say the certificate and key used by this server somehow got hacked or leaked or something like that. Some issue happened and now the certificate is gone, but you see this is valid for up until 19 January 2026. Certificate is leaked, somebody has already taken it now. Now what will you do? Because it is valid, you cannot change the expiry once the certificate is given, right? Now what will you do? You will actually revoke a certificate in your OCSP server. So basically there will be a server which will have a list of all blocked certificates. So this particular certificate which is leaked, right? The certificate serial number you will take and then you will add it to your OCSP server. And now whenever a server try to validate whether this certificate is valid or not, it will also connect to your OCSP server, and then it will make sure that this certificate is not revoked already. So even though the certificate is expiry date is still valid, it will also make sure that using the OCSP protocol whether the certificate is revoked or not. So that list of all the revoked certificates, right, it is called as CRL. So certificate revocation list. So whenever a private CA or a public CA, whenever they ban a certificate or whenever they wanted to revoke a certificate, they will put it into this server, a CRL server, where using OCSP protocol, the servers can go talk to them and then decide whether to allow or not, even though the expiry is still there. So yeah, so these are all the basic concepts. Any questions on this? Like
every public and private set CA will have
OCSP. Yeah, I mean it's optional. You can have it. You can disable that also. But for a more secure server, you should ideally have it.
So when the certificate is revoked, they have to reissue a new certificate.
Correct. The client will get a new certificate, but whatever is leaked, right? But still, it is having an expiry date of longer time. So anybody can maliciously use the certificate and make a connection to our server, right? To avoid that, what we do is like we will add that certificate's serial number into this list. So whenever your server is validating, it will make sure that the serial number is not in this list. If it is there, then it won't allow the connection to happen.
Okay, so basically it is not just the expiry date it looks for the whether it is revoked.
Correct. That is optional. Whenever you are connecting whenever you are making your server, right, your HTTP TLS server, you can actually enable this CRL or OCSP server. You can enable it optionally. If you don't enable it, it will just depend on your expiry. And if somebody stole your credentials, then it will still be used. That is it. But for more security, generally people will use this.
For the private CA, right, a lot of browsers come with the public certificate authority. They have this
Correct.
The certificate
Bundled.
With
Correct.
It. But private CA, you will always get this error
Correct.
that this is not a
Correct. You have to add your root CA certificate and intermediate certificate into the bundle. So there are two places generally. So that also I forgot to discuss, right? So private and public, the very important one more difference is that for all the public one, the big companies actually they will bundle their root certificate into your browser and as well as the operating system. So let's say you have a Docker container, Alpine or even Ubuntu or something, even they have a own certificate bundle. So in that bundle, they will every OS update, right? That certificate bundle also will get updated. So every 6 months or every 3 months, the root certificate provider, right? Maybe Google or something like that, they will revoke a old root certificate. They will add a new certificate. So you will also have to update that bundle, or else you will fall into some kind of a vulnerability that old certificate which is hacked by somebody else, they can actually fake a particular server because the certificate is stolen, right? Now if your OS trusts the old certificate, actually those guys can actually take upon all your resources. Basically, like whenever you make a request, your operating system will not know it is not a legitimate server and it will allow the connection, and it can be a big security risk. So whenever we are updating the operating system related thing, like especially when it comes to Docker images, like container images, you would have seen that there will be a certificate bundle which is getting updated every often. Even though there is no feature specific update, sometimes certificate itself will get updated because they would have removed some blocklisted certificates from the list. And when it comes to applications like Java, right, they have their own certificate bundle called Trust Store. So you will have to maintain that separately. So when it comes to private certificate authority, for Java applications, you have to add it to the Java Trust Store. And for programs like Go and all, in the program you can actually, like in the TLS program, I will show you that where you can add and how you can add and all. But you can either add it there, or programs like curl and all, they will refer to the operating systems bundle. How browsers are having it inbuilt bundle. Go program can also have its inbuilt pool, or you can also put it into the OS. Go can read it from the OS also. You can do it in either ways.
You can disable the certificate check as well, right? We don't.
If certificate check as in, yeah, you're telling that insecure verify false, you're telling that. Yeah, but that if we do that, then there is no purpose of using the PKI. So the whole purpose is to enable it and make sure that we are connecting to the correct server and correct authority.
So let's say certificates have been issued, right? Right now, all the browsers and everything.
Right.
Let's say for today, all the root CA servers are down. Like
OCP servers you're telling.
The main, the CRL server, OCP server,
Huh.
or whatever, all the root certificate whoever issued, right?
Huh.
All their servers are down. Will the PKI thing still work because the certificates are already there? The encryption decryption happened, right?
Right.
So is there
As long as
verification happens or not?
no, it is generally not. The only verification that will happen is this OCSP thing.
On CRL.
Yeah, OCSP is the protocol to access this list. So basically they are together. I just put it together so that I can explain what it is. So if you have a root certificate in your browser, right, it doesn't need any external server to validate. Validation will happen. But if you enable this OCSP, then it will connect. If you don't enable it, then it can work without that. I was telling, right, this is an optional thing. You can either disable or enable it. If you disable it, then once the certificate is issued, right, all you need is the root certificate to validate whether it is signed by this root certificate or not. You don't need to connect anywhere else. It can be done offline.
So by default, this is off for most of the clients.
It depends on the configuration.
For example, or your Go running on a simple Linux server.
Huh.
It is by default off.
It will be by default off. Because you have to go and tell how to. This is for more secure things, like when you are building your own PK infrastructure within your system, right? They will have it. Or else most probably like simple program like curl and all will not do it. They will just depend on the thing, and they will depend on the root certificate bundle by the operating system. As long as you provide that, they will be happy to connect.
And this CRL also gets every now and then updated, or it's only resides in the server, the signing authority?
Maybe the application can have a local cache, I guess, but it will be updated in the server side. Whenever somebody is revoking a certificate, they will update it in their server.
So it's of no use mostly, the revocation list, because most of the clients are actually off.
Hmm.
You are unaware
But
that it has been revoked.
But it depends on the person who's using it. So let's say we implemented it in our local infrastructure, right? We enforce it. So in that way, it will always work. And when revocation list things and all don't work in kernel, right? That is exactly why in the operating system bundle they keep updating it. Whenever you do brew update and all, probably they'll get an updated bundle. So your old certificate will be gone. Like we don't even actually see it, but it is gone from your operating system. So this is that usage, right, which I was telling. So in your client side you will have a public, so both client and server will have a certificate and key. Key is a private key. Certificate is a combination of metadata plus public key. So in your certificate you have a public key. So in the browser, whatever I showed you, right, certificate, if you extract that, you can extract the public key out of it. Public key, anybody will host it outside. So let's say if you check the Amazon's root certificate, right, you can go and check it. Amazon, let's see. So if you go to this website, right, you can download all their public certificates here in two different formats, DER format, PEM format. You can put it into your Java Trust Store or in your operating system. So if anybody is connecting to a server which is having a certificate signed by AWS, it will automatically trust because they release these public certificates available. So likewise, every company provides public certificates. Like even in our Acceldata, whatever we do, we can actually publish it outside. With the public key, what they can do is they can validate whether it is signed by us or not. That is all they can do. They cannot do much, any damage or something like that. So it is very clearly, that's why it was named as public key, because it can be public. So both client and server will have public certificate and a private key, and certificate authority also has a same pair will be there, right? So the usage is like this. So when a client tries to connect to a server, it will present its certificate, and so let's talk about this normal HTTPS, and then we'll talk about MTLS. The normal TLS is like your client is not validated. Your client will validate whether it is connecting to the right server or not. Let's say I send a connection to google.com. Now google.com sends me a certificate. Now using the certificate, I'll make sure that google.com is exactly what I connected to it, or somebody is in the middle acting like google.com. So that I can validate using certificate. So that is your normal TLS thing. So MTLS is, as soon as the client validates the server, client also will present a certificate to server. Server will also now validate whether it is an authorized client or not. So this comes into picture when you wanted to have a very tightly coupled secure systems, like within your organization, like you have multiple components, they want to talk to each other in a secure channel. So you will do it in that way. So both client and server will be validated in an MTLS, and only server will be validated in a TLS.
So it's like both the parties will issue their public key, and then they.
So that's the mathematics magic happens, right? Using your public key, you can actually encrypt data and send it to them, and only if they possess the private key, they can decrypt and see what is inside. So because of that secrecy that we have, the system works very well within the system. And using a private key, you can decrypt it. Also, you can sign certificate. See how root certificate is issuing intermediate, and intermediate is issuing leaf, right? But you cannot issue a new certificate using this leaf certificate and key is also there, right? This is also pair, but you cannot issue new certificate using this thing, because there is something called as EKU, extended key usage. So in the extended key usage, I will show you when we actually generate the certificate and key. You have to define whether what is the capability of this certificate and key, whether it can sign a certificate, it can create a certificate or not, or whether it can be used only for authentication purpose. So you can decide and you can define that in the certificate field itself. So this certificate and key pair cannot generate a new certificate, like sub certificates he cannot generate, but he can generate. So how this can generate is like they have a private key, right? Using this private key, they can sign this certificate. Using this private key, this guy can sign this certificate, but this private key cannot be used to sign certificate, because that when we generate it in such a way. We will add certain fields and all. I will show you the command. In the command, we will show that how these keys are generated exactly, why they cannot generate a new certificate. Any questions on this? Yeah, so it will be there, but it's a trade-off between security and your performance. If you want security, then you will have to.
I understand that when it makes a call, that time both sides will be validated, but again it's making another call after a certain time. So during every transaction,
Yeah.
the mistake happens.
Again, it depends on your security. So you can do that also. You can do like this keep alive is there, right? So likewise, when I make the first, let's imagine that I make the first connection. So my client is making a connection to server. Server will send me back a certificate, server's own certificate. So now I will read the certificate. I will make sure that okay, this server is a legitimate server. Now I will present my certificate to the server. Server will say read the certificate, and then it will decide that okay, this is the legitimate client. Now three-way handshake will happen, and then the connection is established. Once the connection is established, that keep alive thing is there, right? During this connection established, that validation verification is done. Now further calls will reuse the connection. So at that time, this validation will never happen. Now inside your server, there are two different places. There is a verify certificate, there is a verify peer certificate. There are two different calls are there. Internally, there are two different calls are there where you validate the certificate. So in that place, you can actually define For every request you want to validate something, you can do that also. Many of the highly secure servers will do that. We internally what we have does that, but we don't do everything. Like we don't do every validation. We have certain fields, like within the certificate, right? There are many fields which I have showed you, right? There are custom fields you can add. So there are some custom values that I will validate. In my database, I will have those values. Let's say a customer can have multiple environments. So if they use a certificate of one environment to access another environment, I don't allow that. So for that, what will I do is, like in my certificate, I have a field called environment name. So every connection when it was made, I will validate that, but not all this key validation and all. I will do it only once when the keep alive was there. But after that, whenever new connections are coming, right, new egress connections are coming, at that time I will just keep validating that whether this guy is the right guy to access my environment or not. That is one place. And the other place is, let's say your keep alive D is very long. Let's say your keep alive is like some 2 days. 2 days a connection will be keep alive. For some performance reasons you enabled it. Now within the 2 days your certificate is expired. Now your connection is still active, right? It's a security risk. So because of that reason also, you will have to have some kind of a loop within an active connection. You will keep checking whether this certificate is valid or not. May not be like every connection, but at a given interval at some time you have to do that. If you don't do that, then you are at a minor security risk, but it is still a security risk. Your connection is still valid. You have to keep doing maybe spin off another Go routine and then keep checking for this expiry, and whenever expiry kicks in that period, you cut the connection. So when the client tries to make a connection one more time, the certificate is expired, server won't allow it. But if you don't do that, your keep alive will be alive for the next 1 or 2 days, right, until that thing kicks in, ideal connection timeout kicks in, it will still get connected. So to avoid that, we can do that. But again, everything comes with the performance thing. If you have a micro millisecond performance based applications and all, this is bit worrisome, like you have to think about it before enabling it. But for most of the times, people don't worry about it. They enable it, still it will work, everything will work. For something like you are doing some kind of stock market bidding or advertisement bidding and all, only those kind of situations these things will matter, where you will deal with like millisecond, microsecond load and all, you will think about it. Okay, so yeah, so this is on the theory part, this is all I have. And now we have the code part. So before that we can take a break if you want.
Gowtham,
Yeah.
lunch is already there on the terrace.
Okay, we can go have lunch then. Yeah. Yeah.
Yeah, and then should we convene back in half an hour?
Yeah.
Okay, so 1 o'clock we can come back. Can you guide them to the lunch area?
Yeah, just upstairs. We can go.
Terrace.
Yeah. work. So I may
Hello.
That mic.
Yeah, you can speak now and then.
okay. It's working? Okay, okay, great. So now let me go inside this TLS search directory. Okay. So now what it this is like it created a file called CA OpenSSL CNF. So this file is created with the information that we have added in. And the next step is to create the private key. So it created it. So basically what it did is like it created an RSA key with this name, and the key size is like 496. This is like one of the highest level. So the more key size you go, the signing and the verification, I mean basically the signing time will increase. So if you put 2048 bit size, your signing will be bit faster compared to this. The more higher bit size you go, the signing will be bit slower but more security. So now this generated a key. You can see this key is generated, and this is our configuration file. And now, so we are actually making a request that use this key and then create a certificate using this configuration. The expiry is for 3650 days, and the certificate name is this. So basically this is some demo, so I'm doing this 3060 650. Don't do that in any of your. So now you see this certificate is also generated, CSCert. Yeah. Now there is a open. We can use this. So basically what this will do is like this will extract the information from this certificate and it will show you. So we will you can see whatever information we passed, right? You see critical, certificate sign, CRL sign, and CA true. So this is a field that is needed. So this is what makes this certificate a CA certificate authority. Without this field in, this certificate cannot be used to sign other certificates. So if you go above, all the country, state, all the information that I added is available here, and expiry you can see 2025, 10 years, 2035 it is there. So this certificate is now generated. Close this. Root certificate is generated. Now let us create the configuration for our server certificate. First let me create and then we will discuss what it is. So similar fields are there, but if you see here that critical and that information is not there because it is just for the server leave certificate. Similar metadata is available, but you can see here I have added one more field called alternative names. So this CA I have given CN is common name, I have given localhost because our server is going to run in the localhost. In my laptop itself I am going to run the server, so I have given localhost. But if you are generating it for your one of your internal servers or something like that, like maybe dev server or something like that, you need to put that in the CN name. But CN name is something like a old configuration. Now not a lot of these clients and servers will use CN, so they will use this SAN actually, the subject alternative name, right? So this is what most of the softwares will now started using it. So whether you are giving a CN or not, CN you have to give, but whether you are giving it or not, this is really important. You can give your domain names and you can give IP addresses. So let's say you have a EC2 machine, right, and that will have an IP address, but sometimes maybe you wanted to use the same certificate because that machine, that region is not available. You have spin up another EC2 instance which has a different IP, but the domain name is still pointed to the newer IP now. So if you don't put the IP address over there, the certificate will become invalid. So what generally you do is like you either give a wildcard domain, or you will add as many IP as whatever you wanted to add, you will add it here. So this certificate will be validated against every server that we have. So that is this is what being validated when your client is validating whether it is connected to the right server or not. So for that you need to always fill up this SAN values, subject alternative names, and that is the only thing that I have here in this server. Now let us create the key for this server. So here you see, right, I am doing a 2048 key, which is less secure than the root one because I wanted it to be faster. So I will just use the lesser bit size. So now this is the CSR request where I am asking the where I am using the private key to sign the certificate using this CSR using the configuration file. I mean, I am basically creating a CSR. CSR is a sign certificate signing request. So once I have the certificate signing request, I will use that to actually create sign the certificate. So that CSR is now created using this private key and this configuration. And now I am creating another configuration which will contain these SAN values, actual SAN values that I wanted, because here it is an optional thing, I can add it, but here it is a mandatory thing. And here this is the important thing, this is what I was telling about EKU, which I mentioned it over there, that this server certificate is used for server authentication. So when a client wants to authenticate whether this is the right server or not, this field has to be enabled. If not, then client cannot use it for validation. So for server certificate you need to enable this, and here you can see I mentioned CA equal to false. That means this certificate cannot be used for signing other certificates. So this is server certificate extension. So once the extension is available, I will use the CSR file and the extension configuration to actually sign the certificate now. So you can see CSR is here and the private key is here, certificate is here and the private key is here, and this is the extension file. Here the expiry date is only 1 year, 365 days, and it has passed the signature and then it is available right now. Now let us validate this new certificate that we have. can see DNS is localhost, IP address is 127, and you can see this certificate is used for web server authentication. So server auth is the field that we added, and now that you can read it here, it says that the certificate can be used for authentication of the server. And CA equal to false, that means it cannot sign any other certificates further, and other fields whatever we mentioned is available here, and expiry is 1 year, 2026 it will expire. So now the server certificate is generated, key is also available here. This is our CSR, we can remove it later if we don't need it. The CSR config files are not needed. After once we got it, we can remove them whenever we want. And now let's create the client certificate. So for that, this is the client configuration, similar to what we have for server, but server has an IP address, client usually doesn't have, because client can run from anywhere. So we don't have a SAN extension added for that. And I'm creating a private key. Key is generated, same 2048, and since there is no SAN and all those extension, I'm creating a CSR now. Yeah, since there is no SAN and all those things, here also in the extension you can see there is no SAN mentioned. Similarly, CA is disabled, CA is false, and extended key usage here is the client auth. There if you would have seen, it is a server authentication when you create a server certificate. In the client certificate, when you create it, it is a client authentication. So this is done, and now we will create the actual, sign the actual certificate using this CSR. So now this is also created. So now we will validate the client certificate. So you can see TLS web client authentication, there it was web server authentication, and CA equal to false, and above you can see expiry is 1 year, and same metadata that we have for organizations and things. So now we have the client certificate, server certificate. So this one is I'm creating a single file of both the client certificate and key together. Like curl, when we use curl, right? Curl can actually use a single format like this. You can actually specify certificate separately, key separately, and then make a call, or you can have a single certificate with key also to make a call. For convenience purpose, we can actually have a combined key if needed when you wanted to use it in some kind of a curl like application. If not, then this is not needed. And these are all the files that we don't need anymore after we generated the certificate, CSR and all those things. I'll just leave it as is for now. So now we have created all the things that we needed. You can see our CA certificate. CA certificate is there, CA private key is there, client certificate is there, client private key is there, and server certificate is there, server private key is there. These are all the only things that we need. And the CA certificate, right? The CA certificate is now what? Now it is it public? No, right? It's private. I created it locally. Now when my Go application tries to validate, right, it doesn't know this CA. So it will fail actually. If I don't give this certificate, CA root certificate to my Go application, or if I don't add it to my OS, my application will not use it, will validate the certificate as an invalid authority. So for that I will need only the certificate, not the private key. Private key is only used when I am generating the client certificate and server certificate, but the CA certificate is needed everywhere wherever I am using the TLS. So now we will go back to the code. So all of the files are inside the cert directory. Now let's go to the server. So here as usual, like this logging things are there, just compress them. And here I have two functions. We'll come back to the function. Before that, we'll come back to these functions when we actually read the code. Yeah, so this is the main. So here I am initializing the logger, and here we have our usual timeouts. One extra thing added here, TLS handshake timeout. So now one more timeout is added into our function, that how much time the server can wait for TLS handshake to complete. Because even the client side, they can even do an attack that they can take a very long time for the TLS handshake to complete. So if they have some thousands of hundreds of clients, that will stall your server. Basically your server is supposed to serve somebody, won't serve because of this issue. So you will have to have a TLS handshake timeout also. So that I have defined as 5 seconds and address the port that it needs to bound to, and the server certificate file and server key file, and this is what I was telling, right, the CA root certificate. So I am adding the root certificate only, not the key, only certificate I am having it here, and server certificate and server key are there. And what I am doing is like there is a client CA. So what I am doing is like I am loading this certificate, right, I am loading this and then I am getting a certificate pool out of it. So that is this function. So what I am doing is I am reading that CA file and then I am creating a new certificate pool where I put that certificate inside, and then I am returning that pool. So basically this certificate pool will be used in my server. So let us say this is one CA server, right, I can have more than one CA servers, and then I can add them into the same pool. Now that my server will be able to validate the certificates from any of the CA servers. So this will come in handy when you have multiple CA servers. For let us say you have multiple departments, multiple subsystems, each one can have, for security reasons, each one can have its own PK infrastructure. That is one reason. The other reason where this can helpful is like every certificate, like I showed you, right, the certificate is for 10 years root certificate and the normal certificate is for 1 year. So after 10 years this root certificate is going to expire, right, but you don't need to wait for that long. So what generally people will do is like this is 10-year validity, right, for the root certificate. So 9th year they will release one more root certificate for next 10 years, and then from that day onwards they will start signing a new intermediate certificate or a new client certificate. They will start signing using that new authority. So within 1 year is their period that they will rotate all the old certificate and then they will be replacing it with a new certificate. So that is how generally you do it, because in just one afternoon or one evening if your CS server is expired, then all your existing certificate that you issued will be gone, because what we use to authenticate, we use that CS certificate to authenticate. The CS certificate will be expired in 10 years. Now any client certificate that you issued is gone. So for that reason you can use a CA pool where you can have more than one root certificate, like in the 9th year or 8th year you will create one and then you will load it into this certificate pool. So for a buffer period, both your old certificate signed applications, new certificate signed applications, both will work with this server. So yeah, you are loading that CA certificate, and then here you are loading the public certificate and the private key, which is specifically meant for this server. So that I am doing it here. You can see load 509 key pair. You put the certificate and key file there, and then in return you will get a TLS certificate object. So this also you will pass it into your TLS config. So now I loaded the CA certificate pool. I have my server credential pair, and then this is also one important configuration, that what is the minimum TLS version that you support. So any TLS version that is lesser than 1.2 is vulnerable, very pretty old, and then they have some known vulnerabilities. So the minimal version ideally you should start supporting is 1.2, and we have 1.3 as well. But depending on the minimal version, if you put, client can decide. Client, if the client only supports 1.3, it will still work. If they support only 1.2, it will still support. But if you put minimal as 1.3, 1.2 clients won't support it. So you put the minimal value as 1.2, so both 1.2 and 1.3 will support. And you will put the certificate with the certificate key, the pair that we created here, you will add it to the certificates list, and then client CA, you will add it to the client CA here, which is the certificate pool, and then prefer server cipher suit, right. So basically now you have provided the certificate and key. Now using the certificate and key, how to encrypt, right. There are many cipher suits are available, many ways which you can use this key and certificate to encrypt the data. So these are all some of the good, tough, battle tested cipher suits. Maybe some old applications may use a old cipher suit as well. So to avoid any security risk, generally servers will provide a list of cipher suits, and the client can pick any one of it and then it can start communicating. So when the TLS handshake happens, right, so after this certificate validation verification was happening, during that negotiation it will also send this cipher suit list, and then it will tell the client that I support all these list of things, you pick any one of it. The client will pick one of the options that it optimized for the client, and then it will send back to the client server saying that okay, I will use this cipher suit now. So if none of this were supported by the client will show, server will throw an error saying that client doesn't support any of these things. So this is important for security also. So whenever you implement something like this, you should also manage this. Many of these banking sector, financial companies will actually have their own list of cipher suites. They will even reduce it. They will even say only 2 or 3 supported cipher suites, which is highly secure. They will not support anything else. They will drop everything else. So you will need to maintain, every organization generally have to maintain their own cipher suites according to their compliances and certifications that they own. So now I have created a TLS configuration using these values, and that TLS config, I am creating a server right now. This is our usual server that we created it over there, right? So in the HTTP server itself, and this is our regular handle function. This TLS part I will come back. We'll come to this later, but think of it like another handle function that we have. And this handle function, what it does, like it sleeps for 2 seconds and then it sends a response back called response complete. And now some logging I have added, and you can see I am creating a listener on my own. So TCP listener with the address that we have. So actually when I create on my own address, we don't need to mention it here. This is not needed. So this anyway, even if I mention that, this will take precedence, because this listener will take precedence if I explicitly create it. And now what I am doing is, like, I am creating it, I am getting this TCP listener, I am wrapping it on top of our TLS config that we created. So this is our plain TCP thing. Now you are adding TLS to it. So TCP plus TLS will become your HTTPS part. So now I have wrapped it. So now this is the TLS. Your normal listener will become a TLS listener once you add TLS config. So now this TLS listener, you will add it to your timeout listener. So I am creating this custom timeout listener because that is the only way I can add a TLS handshake timeout. If I don't do this, if I directly pass this object into my server, right, I don't have a way to configure my TLS handshake timeout. I wanted to control how much time my TLS handshake can take. So if I want to do that, then this is the only way. I had to create my own timeout listener, and in that I will configure my own TLS handshake timeout, and then I will pass this timeout listener into my serve function. I can actually pass TLS listener directly into this also, but the problem is, like, I won't have a way to control my TLS handshake timeout. That is why I am having my own thing and I am adding it here. So this is that whole server code, and let's see what I have it in the client as well. So this is our regular logging initialization. So here also, if you see, same way how I loaded the server key pair, I am loading the client key pair here, and I am getting a TLS.certificate object. Same like that. I am adding a root certificate. There I added a get the CA certificate, and then I added to the certificate pool. Here also I am doing the same thing, getting the CA certificate, adding it to my, since my CA server is a private CA server, I had to do this. If not, then this will be provided by the OS bundle, then I don't need to do this. Initialize the logger, and this is our regular configuration that we have. And here I am loading the certificate and the private certificate, and I am loading the root certificate pool. Same thing like how I did it in the server, certificate and key and the root certificate. I am creating a TLS config here similar to that, but the only difference will be here you see it is a root CA certificate, there you would see it is client CA. See, in the server side it is a client CA, because in server what are we validating? We are validating the client certificate. So here it will be a server CA. In client we are validating the server certificates, so it will be a root CA here. So in this root CA, if the root CA certificate is present, from server whatever certificate is coming, we will validate against this one. And here also minimal TLS version that we support, I am adding it, and here which server I am going to connect to. This should match with the certificate that we have generated. Localhost is what we have given it, right? In the DNS we have given it localhost. So you will mention server name is localhost, and cipher suite it is exactly the same with server whatever I have. So even if you remove some of them here, it is still going to work, because at least one of the cipher suite works. As long as it works, our thing will work. So I will just remove it for demo. So here I am supporting only 2. Here in the server side I have all of them. So when I am negotiating, the client will pick either one of these 2, because that is also supported over there. So this is what you were telling me, insecure skip verify. So here we put it false, because if we put it true, then that completely invalidate whatever we are doing for the security. So now TLS config is ready. For client, your HTTP transport needs to be created. So there you will pass your TLS config, and then here your dialer timeout will come. Like in your normal HTTP also you have dialer timeout, right? That's the same thing. And here we have a TLS handshake timeout. Same thing like we have it in the server. In client also we have a TLS handshake timeout here. And we have we will create our own HTTP client with the custom transport and timeout that we wanted to have, and we will do a get command into this particular URL that we have. So once we make this call, TLS handshake and certificate validation, everything will be done within this call itself, and if there is going to be an error, it will come at this point, request failed time it will come. So once the request passes, we will get the response and we will parse it, and then we will show it in the screen. So that's what we have it in the client side. So let's run this server and client right now. So I am in this directory where we have all the certificates and all. I am going to run the server right now. So in my server program, right, I mentioned the certificate name like this. So that means wherever I am running from in the current directory, it will take the files from. So I will run this server. So server has been started now. So client also I am in the third directory. I will just run the client directly. You see 200 success, it's HTTPS. So this now we have a working HTTPS server which is signed by our private authority, which is working right now. You see 200 also came. Right. So this is normal TLS, not MTLS yet. So you see this message says no client certificate. So what it does is like the client, when it made a call to server, server sent a certificate and the client validated it against the root certificate that we added into the pool, and then it accepted the connection. That's it. And now this is our normal HTTPS thing. Now to make it MTLS, right, it's very simple now. So once you reach here, to make it MTLS, what we need to do? Now we need to enable client authentication, because server authentication is by default. Just uncomment this and then you will say this verify certificate, this is like a default value that is coming from the library. So you can say this client authentication equal to require and verify. There are multiple options. You can say that not to verify, all those things like same like insecure verify is there. Right? Likewise there are some options here, but this is the right option. When you put require and verify, that means when the client is making a connection, it needs to pass the certificate. If it doesn't pass the certificate, then it will reject. The handshake will fail. The second option is verify. After the request, you have to verify it. So both are added into this section. Now I save this and I will rerun the server. So here also you see that same message got printed. Request received without client certificate. Now we have uncommented it. Now if I rerun the server, I rerun it. Now let's go back to client. I am running the client. Now you see response is 200, but you see now mutual TLS, your certificate CN is localhost. It came last time, it says no client certificate, some message came. This time it says that you have a local host specific certificate with you. If you go to the server, here also you will see client CN is localhost. So now we have enabled the MTLS, which is working. So now to showcase that what will happen if I don't send my certificate. So I'll go to my TLS. This is my certificate pair, right? I'll just comment this guy out. Okay, now I'm not sending the certificate pair anymore. Now let's see what happens. Server is still the same. Server now needs the certificate, but my client is not going to send a certificate. See what it says? Server says certificate required. So when a server is asking for a certificate and you don't send a certificate, this is what the error that you will get. Now, without touching the client code, using the server if you want to solve, so go to server and don't ask him to do the client authentication. If you comment this thing out and run the server one more time, now this call should work. Now I run the server. Now my server doesn't have the client authentication, and I'm also not sending the certificate. Now things should go through. Request 200 status. So now this has become normal HTTPS. Client validated, but server doesn't want to validate, and client also didn't send it. So what will happen if you send a wrong certificate and key? Let's say it is signed by somebody else. You will exactly get the same message, certificate required, but you will be confused thinking that I pass a certificate and key, why is it asking for certificate required? Actually what it means is the intended certificate, the certificate that it wants to see is not there. So it says certificate is not required. Even though you pass it, it is not what the server wanted. So you will exactly get the same error. So that is what I have it inside this exercise. Basically handshake timeout on both server and client side, TLS handshake timeout. So to make the timeout happen, right, I have added some more delay into the TLS timeout period. So basically that will delay the handshake time. You can see, right, dialer timeout. So this will be very, very less. So because of that your timeout will trigger. Maybe you can run and check it once you get some time. Even if you want to run it, you can run it now and then check it out. Yeah, so I think that is it. Mostly that's what I wanted to cover on the TLS and MTLS side. So let me know if you guys have any questions, anything to discuss, we can do.
For the MTLS client cert, right?
Huh.
So normally all the certificates are essentially proving the identity of something. For a server, the identity is generally domain name and the
SAN.
Hash, SAN and the CN, one of these.
Right.
And this is canonical name and the C names basically for the canonical.
Yeah, any different names that you want to refer your server into, it will be in SAN. So modern systems started trusting SAN instead of common name.
So now what is the identity for a client? Client doesn't have a server name, right?
The certificate is signed by who?
The CA you are saying. And only the server auth has the requirement of CN and SAN.
So server has that CA root certificate, right? And the client certificate is also signed by the same root certificate. So when a certificate came, it will go and check whether this is signed by a certificate which is in my trust certificate pool. So if the certificate produced by this client is signed by any one of the certificate from the trust pool, it thinks, okay, this is a valid certificate. And that happens within your TLS thing itself. You won't receive any HTTP error code or something like that, because it happens within your TCP, within your TLS handshake itself. So you will actually receive blunt errors, which will say certificate needed or certificate is invalid, something like that. You will get those kind of errors. You won't even see any HTTP code. That actually you can capture, you can do a catch and then you can transform into a meaningful thing if you want. But generally it doesn't throw anything by default.
And I think in similar variation, we use this in Kubernetes as well for the kubectl code.
Exactly, exactly.
The server name, we use it for the
Correct,
application.
Correct, correct. That is exactly. There you will see a public certificate and a private key you will see. Both will be there in a JSON format. So when you send it, your API server will check against it. Yeah, check against it. When you are getting it itself, it was signed. When you make an API call, for every API call, this guy will check with that certificate and key. There you have an RBAC system, right? So this certificate is mapped to a particular permission and all those things. So that exactly works the same way. That is actually MTLS, if you see, because client side you have a certificate and key. Server side anyway client will validate by default when it comes to TLS. Cool. Anybody else have any questions? Anything?
Could you talk about any production issues that has happened?
So production issues mostly with the timeouts. That's what. So if it most of the times when timeouts comes, we always think about network, right? But we need to check these first before we go into network. So here the network side part is like TLS, that handshake timeout period. So handshake timeout period can cause things like if you have a very busy server, so many connections are there that you are asking about latency increase. So if you have a very small server, too many connections are there, maybe it can take some more time to complete the handshake, and meaning that time your client can get timeout. So you can come up with the sane timeout configurations on this. And production issue, one more thing is like people forgetting to renew their certificate. So that is one more issue on this. So like if you have a period of expiry date and all those things, you have to maintain your certificate pool properly.
From this renewal of certificate, so let's say like we have a role.
There is no renewal kind of a thing. You practically get a new certificate and then add it to your pool. Old certificate, once it expires, it's gone.
It's gone. I mean, so we have to reissue certain key also to the client as a server. Yeah.
Certain key, yeah, exactly. So if the root certificate is going to expire, all the certificate is signed, right? Everything will get expired.
Right.
So you have to pre-plan for it. When you are running your own public infrastructure, you have to plan for it. Let's say your root is 10-year expiry, your intermediate is 5-year expiry, and your leaf is 1-year expiry. So every 1 year your intermediate, you will keep regenerating the leaf certificate. Every 5 year every 5 year you have to have a different intermediate also. So in the 4th year itself you will release one more intermediate.
Okay.
And in the root, when it is expiring 10th year, then you should have one more root server, root CA by the 9th year or 8th year itself, so that you can start issuing new certificates to people over a period of that 1 year or 2 year. Everybody will migrate into the new infrastructure. You have to plan for it, and then it comes with a lot of these operations as well, maintenance headache.
How do you manage this in a production environment? Let's say you said there are 9,500 servers, right?
Yeah.
And how do you maintain certs for everything? Because whenever the
We create we create an API service basically that takes care of everything. And AWS has this also comes with, so here, right, if you see in the certificates directory, this CA certificate is fine, giving it to public, but the CA private key, right, this is really critical. Nobody should have access to it, not even the person who generated it, and nobody should have access to it in a plain text as well. And according to compliances, you should not hold it anywhere. You should not, this should not be accessible by anyone. That is how compliances come. If you don't have that kind of infrastructure, you don't get the compliances certificate itself. So for that, what we do is like this CA certificates as well as intermediate certificate and the keys, right, are our intermediate keys and CA keys are stored in AWS KMS. We use AWS KMS as a service for that, right? So we use it and then we generate the key over there. So AWS makes sure that nobody has access to the key. Even AWS doesn't even have the access to the key. What it can do is it exposes an API which I can give a CSR, certificate signing request, to KMS, and KMS will sign it using the private key and give me back the certificate to me. So can I request the certificate to download? No. Can I request the certificate to see as plain text? No. Can AWS see the private key? No. Nobody can see that private key at all. So that makes sure that the compliances are satisfied. So in our production system, our root private keys and intermediate private keys are managed by KMS. And whenever I need to issue a new certificate, I make a CSR request to the KMS, and then it signs it for me and give it back to me. AWS stores it,
But it
and as per their documentation, even they don't have access to it. The only way they have is like a API exposes a signing thing. Nobody can go and read about it, read the key in plain text. And even in the rest it is encrypted. So when you use KMS, it solves a lot of these compliances issues. And when you wanted to do it on your own privately and all, probably you can use something like Vault and all to secure it. But again, I don't know how much comfortable this compliances auditor will be when they see, because Vault is also hosted within your system. So you have to have some kind of a high level infrastructure security with you to hold this kind of things. Or maybe a physical device. Put the key over there in the physical device. Whenever you want, you use it, and then you put it into some kind of a locker. Nobody else can access it. Something like that. But that all comes with a different auditing level and things. So easiest way at this point is like for us is KMS. So we stick to KMS and we are using it. And we have an API service. Any other service of us can go and request a certificate for their department, like this organizational unit which I showed you, right? So that will be different for each service. So they can go and request and get a certificate with a particular expiry and all those things. When they wanted to rotate and all, they had to make a new request and get a certificate. So basically this API service is just a front end. It just signs and provides certificates and keys to the people whoever needs it. Whoever creates the certificate has to manage the life cycle of it. So they will.
Like, is it part of CI/CD or something? Because
It's part of the.
certificate has changed. For example, the intermediate certificate is expired. Now you need a new intermediate.
No, that is taken care by this.
No, that is created.
No, that is.
The problem is not that.
Huh.
How do you distribute that to all the 100 services?
The services has to come back and check because the expiry date is there.
I mean, where do they check is the problem.
Expiry date of the certificate. So you can have a routine like before 3 months or before 6 months of expiry, you go and get a new certificate.
I mean, how is it automated is my question.
The service itself has to do it itself. Like service itself has to check.
The devs will do it or?
The devs has to do it. Whoever creates a server, right, service, right, they are doing it right now. Right now they are doing it. But if there is a better approach, we don't know that yet. But right now the service itself, like, so the service that we developed is like, it's a hand-off service, like it just creates it and then it manages the life cycle of the root certificate and intermediate certificate. But it doesn't manage the life cycle of the leaf certificate. That ownership is given to the person or the service who actually generated it.
Maybe the CI/CD, at least for the root pool, right, the third pool, you need to keep updating it, right?
So what we do is on the server side of one of our main application, what we do is the Prometheus matrices that it exposes, right? It exposes the expiry date as a metric. So 60 days before we send an alert. It should auto renew. If it doesn't auto renew, 60 days, less than 60 days, if the expiry goes, we send an alert using Grafana and then it will reach everyone. So that is on the server side that we do. But client side, client has to take care of it because it is there. They are the one who is the owner of the certificate. I don't even know whether the certificate is being used or not because there is no online connection, no. And there is one more thing that we did is like that OCSP. In our infrastructure, we don't have an OCSP. Instead, we have something like OCSP, but not OCSP. What we did is like we have a Redis database where I have written an API for, on top of that. So basically, OCSP, what it does is like it adds the serial number of blocked certificates. So whenever a request comes, it will go and check the serial number is there in the list or not. If it is there in the list, it will block. So what we did is like our infrastructure is very small. We did the inverse of it. All the active certificate serial number we add to Redis, and I put an API in front of it. My server, whenever a client makes a request, first thing is certificate validation. It will do anyway, TLS it will do. Once it does that, in the peer side, what I do is like extract the serial number of the certificate, check it against my Redis database. The serial number must be there in my Redis. If it is there, that means it is an active certificate. So when somebody leaked the certificate or when some of our client is gone, like they are not in our sales anymore, like they didn't renew their subscription or something like that, I remove the serial number from my database. So in that way, whenever they make another connection, the server will reject the connection, saying that your certificate is revoked. Since our infrastructure is smaller and bit different, we did the inverse for the OCSP. I didn't use the OCSP protocol, but I did an API. My server is Go code, right? So you have a very good advantage when you develop both server and client. when you are the owner of both the codes. When you are owner of only one of it, the other one is controlled by somebody else, you have some difficulties, you have to cope with something. But when you have both of them in your control, you can actually tweak a lot in that.
But that means it's a single point of failure. Your Redis, the OSCSP server.
No, but Redis can have multiple.
No, the server itself is down.
Which server?
Your OCSP server. For whatever reason.
No, but it can have scale up and all those things.
What if it's always possible, whatever you have, if you upgrade or let's say your region goes down, blah blah blah, or your server itself.
Replicas. We have replicas, we have replica region, DR regions are there. So it can always make another call. And this is again, this is with the security trade-off. If I cannot access my OCAP server, right, I will reject the call. Even though, because I don't know whether it is there in my database or not, I will reject the connection. That is the trade-off between my security. I can allow it, because I cannot access it, I can still allow it. But that again comes with the security risk. In a highly secure environment, it's a trade-off. So we will always reject it. If I cannot access it, if I cannot validate, I will always reject it. I will come and check the consequences later. But first thing is security. So we will reject it.
It's like license server also, right? In a way.
Huh.
Like your license is checked as a.
Correct. It is something similar to that. But single point of failure, again we have DR and all those things. It's again running in a Kubernetes, so it has its own thing. It can figure it out. Like if you know.
You have a lot of confidence that the server doesn't go down.
Because we've been running it for a very long time. See, it is not about server not going down. I'm pretty sure server will go down, but DR will kick in. See, 5 minutes downtime is tolerable, fine. 2 minutes downtime is tolerable, fine. We have like 99.4959, right? So yearly 1 hour or something like that we have. So within that time, if we can kick in, that is fine. We rigorously test our DR systems very often, like every month or every 1.5 months or something like that. We manually trigger it. We have that advantage of Kubernetes cluster I told you, right? We have our individual clusters. So we time to time we spin up all these things. We actually simulate all these scenarios. So that is one perk of having our own data centers. We have infinity resources basically for a cheaper cost. Cool. Then if anybody else has anything, then we can close it. Cool. All right. Thank you guys. This some feedback form is there. If you guys can scan and fill it.
You can scan the QR and fill feedback. It will be very good for Gowtham and for customer.
Yeah. Please feel free to add any comment, anything, so that next workshop will be good. So this is my first time, so I'm asking for very open feedback. Please do it.
Stop the streaming and recording.
Where is the button?
Here, these the two blue ones.
Oh, one by one?
Yeah, one by one.
First streaming. Oh. No, button is